Hello and welcome back to Sheaff Math. In today's lesson, you're going to be able to find a solution or a point of a linear equation. Now let's talk about linear equations real quick. What is a linear equation? Well, they come in all shapes and sizes, but here's an example of one. One thing that's pretty standard with them is that there is an x and a y involved. And why do we use the x and y? Is because they're coordinated with the xy coordinate plane. And a linear equation creates something on the graph. And so what it always will create is a straight line. That's why it's called linear, because it makes a line. Now, this line isn't just some random brush of a pen. It actually is made up of infinite numbers of points on there, okay? And it goes on forever in both directions. Now the points that you look at on this particular line, if you look between 2 points, there are infinite number of points there too. All right, and we call these solutions. These are solutions to the linear equation. And the way that we write these solutions is through what we call a coordinate pair or ordered pair. And we use the x and the y to help us find the point on the graph. Now, let's look at a point real quick. Now, some points are better than others, in my opinion. Some of them are nice and easy for mathematicians, and some of them aren't so nice. This one happens to be a real nice one because it's sitting right there on a crosshair point, or a bullseye right there, because it has whole numbers as its coordinates. And so this one happens to be -2, 1. -2 is the x, and 1 is the y. And so all along this line, there are infinite number of points that have coordinate pair names. Now, let's take a look at this line real quick. Now, we know that this line goes up and to the right, and it goes down and to the left, and it goes infinitely. Well, what it's doing, it's actually going to the left infinitely. It will go forever and ever and ever and ever, and if you pick a number on the x-axis, it will eventually cross that number, and the same thing goes for the left-hand side. Now, what does that mean? That means that this line is going to cross or cover every number on the x-axis from -infinity to +infinity. And now, let's suppose that you were given the task of finding some random point on this equation. Now, it'd be easy to look at the graph here because we have it already here, and there's some nice easy points. But there's a way that you can find a solution without using a graph. And so what you're going to do is you're going to pick any number that you want, because every x has a place on this line. And so we're going to pick a random number on the x-axis, and I'm going to pick 5. And what I'm going to do is I'm going to take the original equation, and I'm going to substitute the 5 in for the x, and then I'm going to simplify. And what happens is, after I multiply 3 times 5 and then add 15 and 7, I get y equals 22. And so 5 was my x that I randomly picked, and it turned out that 22 was its pair mate, right, the y. And so at 522 on this coordinate plane, this line will go through it. So let's take a look at it. If we start at 5, our x, and we go straight up, it's going to be off the graph actually. Now, if we take that line and continue it on, it's going to meet at some point, probably off the computer screen here, and it's going to be at 522. So you can do this. You can find as many points as you want. You can use easy numbers. If it doesn't matter, you could use a 0 or a 1. It would be just as easy. I'm just using random numbers to show you anything could be possible. You could even use a decimal or a fraction. Now, what that means is we really don't need a graph in order to find a solution to an equation. I mean, you could graph this, but it might take you a little while to do it. But if you were just asked to find some random solution, all you would have to do is, well, pick some random x. I'll pick 20 for here, and I'm going to substitute that in for my x in the equation. I then simplify. Negative 4 times 20 is negative 80. Plus 12 makes negative 68. And so my solution is 20, negative 68. At that point on the coordinate plane, my line will go through it. Let's look at a few more examples. So y equals 2x plus 5. I'm going to pick a random number, 6. I substitute 6 in for the x. I have an easy simplification here, and I get y equals 17. That 617 is the solution for y equals 2x plus 5. Now I have a decimal in my equation, and so I'll pick some random number again. I'll pick 7, and so 3.5 times 7, after I substitute that 7 in there, is 24.5. I add that to 20, and I get y equals 44.5. So at the point 7, 44.5, my line will go through that. And you can do this with any number for x. Here are a couple more examples. These are kind of ones that are just a little different and sometimes confuse students. This one happens to be a very simple one, but a lot of students get confused because they see the x and the y, but they don't see a number at the end. Well, there actually is a number, but it's 0, and so we would never put plus 0 here. And so if you think about it this way, it doesn't look so different than the one we just did. But many of them don't have the number at the end, and so all you have to do is pick a number and put it in for the x. I'm going to pick 3. So 7 times 3 is 21, and there it is. So that's really, really easy. Now I put this one here because this one comes up sometimes, and you're asked maybe to find a point for this. And some of you may be asking, well, where is the x? Well, there is an x, but you can't see it because it's really 0x. There are no x's, and so this is what the equation would truly look like if it had an x and a y. And so what you'll see here is that if I put a number in for x, it's going to always be 0, and so I'm going to have negative 14 left over as my y. And every point on this particular linear equation is going to have negative 14 as its y, because no matter what number I put in there, I'm going to be left with negative 14. Now, what does that mean? How can you always have negative 14 as your y? Well, imagine a straight line going through negative 14 horizontally. Okay, it's a flat line. And so it doesn't matter what x you pick along that axis, it's always going to be going through the negative 14. And so that's why this one's just a little bit different. Well, I hope that helped, and I hope you learned something. If you need to watch it again, I encourage you to do so. Anyway, thanks for watching, and we'll see you next time.